We're looking at homework from section 4.2. It's question number 12. This is a big one. 82% of adults want to live to age 100. You randomly select 5 adults and ask them whether they want to live to age 100. The random variable represents the number of adults who want to live to age 100. Complete parts A through C below. Construct a binomial distribution. Graph the binomial distribution using a histogram and describe its shape. What values of the random variable x would you consider unusual? Part A. Construct a binomial distribution. So we'll apply the binomial probability formula because either an adult wants to live to age 100 or they don't. There's 2 possibilities, so that makes this binomial. To use the binomial probability formula, we need to have the value of n, which is 5, because we selected 5 adults. We also need to have the value of p, and p is 0.82. So the binomial probability formula says that the probability of exactly x successes is given by ncx, p to the x, q to the n minus x. So we need some additional values besides just n and p. We're going to need the value of q, and then for the value of x, we're going to plug in 0, 1, 2, 3, 4, and 5. So for the probability of 0, we have 5c0, p to the 0, and p is 0.82, times q. If p is 0.82, then q is 1 minus 0.82, which is 0.18, to the 5 minus 0, which is 0.00019, rounded to 5 decimal places. For the probability of 1, we get 5c1, 0.82 to the 1, 0.18 to the 5 minus 1, which to 5 decimal places is 0.00430. Probability of 2 is 5c2 times 0.82 to the second times 0.18 to the 5 minus 2, which to 5 decimal places is 0.03921. The probability of 3 is 5c3, 0.82 to the third, times 0.18 to the 5 minus 3, which is 0.17864. Probability of 4 is 5c4, 0.82 to the fourth, 0.18 to the 5 minus 4, which is 0.40691. And then the probability of 5 is 5c5, 0.82 to the fifth, 0.18 to the 5 minus 5, which is 0.37074. So these are the values that you would use to fill out the binomial distribution table in Part A. For Part B, we're supposed to graph the binomial distribution using a histogram and describe its shape. So we have several different choices over to the right, and if we look at those, we want to be able to match up the values that we have in our binomial distribution to the graphs that we see. In our distribution, the highest probability happens when x equals 4. So if we come up to the graphs and we look at x equals 4, is that the highest bar? For graph A, it's not. If we go to graph B, it's definitely not. It actually looks like the lowest bar. For graph C, it is the highest bar. And for graph D, it's not. So the only possible answer here for the choices that we were given is answer C. And then if that is in fact the answer, then what is its shape? So we see the high point at 4, and then it tails off to the left. It goes 3, 2, 1, 0. These are small little bars here. It's a tail to the left. When a distribution has a tail to the left, it's a skewed left distribution. So that's the answer to Part B. What about Part C? What values of the random variable x would you consider unusual? So we have 2 blanks to fill in. I'm actually going to fill in the second blank first because it's important for us to know that answer before we answer the first blank. So the values blank would be unusual because the associated probability or probabilities is blank 0.05. So what's our criteria for being unusual? And the criteria for being an unusual result is that the probability is less than 0.05. So that's how we decide if something's unusual. Is it less than 5% probable? Now we can go up to our binomial distribution that we created in part A, and we can judge each value and ask, is that value less than 0.05? So for x equals 0, that value is less than 0.05. For x equals 1, that value is less than 0.05. For x equals 2, that value is less than 0.05. But 3, 4, and 5 have values that are greater than 0.05. So x equals 3, x equals 4, x equals 5 are not unusual, but 0, 1, and 2 are. So when we're making our choice for the first blank, we're going to pick this third choice down, x equals 0, x equals 1, and x equals 2. And that's your answer.